Good morning. Properties of trig functions, what we did last time, right? We looked at domain, range, the graphs, amplitude, period, things like that. We're going to look at what's called the inverse trigonometric functions today. So go back, think back, start the semester. What are the only types of functions that have an inverse?
Rational function?
So rational functions will have, some rational functions will have an inverse, but it has to be a specific type of function.
One-to-one?
One-to-one functions are the only ones that have inverses. Other trig functions, one-to-one. No, by definition of periodic, they can't be one-to-one. So technically speaking, they do not have inverses. So why are we looking at the inverse trigonometric functions? You should also recall that we can make any function one-to-one simply by restricting its domain. That is what we do. We take each of the trig functions and restrict the domain in such a way that not only does it cover the entire range, but it's one-to-one. The domain of a function, what does that become with its inverse function?
It's range.
Its range. So the important thing to note is the range of each of these inverse trig functions, because that shows you how we restricted the domain. First up is the inverse sine function. Obviously, domain minus 1-to-1, because the range of sine is minus 1-to-1. The range minus pi over 2 to pi over 2. And if you think of the unit circle, what part of the unit circle is that? So what part of the circle is minus pi over 2 to pi over 2? What part of the circle does that cover? Because the whole circle would be what? 0 to 2 pi, right? So it's minus pi over 2 to pi over 2. Maybe think in terms of quadrants as well. What quadrants are minus pi over 2 to pi over 2?
Third quadrant? Second? Fourth?
Fourth quadrant. There is a fourth quadrant in there. First and fourth.
Yeah.
It's the right semicircle. Notice why they chose minus pi over 2. Otherwise, you have to split it into two intervals. Maybe 0 pi over 2 and then 3 pi over 2 to 2 pi. That's kind of a mess. So he said, we'll just make it negative. We'll make it pi over 2 covers the same thing. The inverse cosine, same domain, the range 0 to pi. Again, think in terms of the unit circle. What portion of the unit circle is 0 to pi? Minus pi over 2 is the right half. What's 0 to pi?
The left half.
Hmm?
The left.
Won't be the left.
The top half.
Top half.
Yeah.
It's quadrants 1 and 2. Right, so for the inverse sine, we have the right half. For the inverse cosine, we have the top half. And generally speaking, those are the only two parts we're going to be looking at. Right, that is just how they decided to restrict the domains. You could have done it another way to still make them 1 to 1, right? It's not the only way you could have done it, but this is how we chose to do it. Inverse tangent. Remember, the range of the tangent is all real numbers, so its domain, the domain of the inverse would be all real numbers. Its range, open interval, minus pi over 2 to pi over 2. Remember, the tangent function is undefined, where cosine is 0. It should be at negative pi over 2 and positive pi over 2. Comment on the notation. This is the more commonly used notation. You may also see the arc notation, arc sine, arc cosine, and arc tangent. They're just the inverse. So it just depends on the reference, the text that you're looking at. The inverse secant function. It's going to have a domain of everything except the open interval minus 1 to 1. Its range will be the range of the inverse cosine, taking out where cosine is 0. So 0 pi, taking out pi over 2. The inverse cosecant, same domain. Cosecant's 1 over sine, so we're going to use the same portion of the unit circle, the right half, and then take out wherever sine is 0. So the range of the inverse cosecant minus pi over 2 to pi over 2, taking out 0. And then finally, you have the inverse cotangent, whose domain is all real numbers, and range is the open interval 0 to pi. That's it. Those are your 6 inverse trigonometric functions.
Can you go to the first side just for like 1 second?
Good.
Like just for 1 second.
But I mean, you also could have come in on time, right? So
Just so I can take a picture.
I'm in a mood. I'm going to take 30 points away from your final grade for this.
Shit.
So that's the cost. Nothing's free. Evaluate sine of the inverse sine of 1/2. What we want to do, 1/2, is that in the range of sine?
Yeah.
Yeah. Which means the sine and the inverse sine undo each other. That's kind of the definition of inverse functions, right? F of f inverse of x is just x. That was easy. Cosine of inverse cosine of -1/2. -1/2, is that in the range of cosine?
Yes.
Then that would just evaluate out to -1/2.
One minus 1 instead of
What are you taking the inverse cosine of?
1 minus 1.
Ah, okay. So now it's cosine of the inverse sine. Well, sadly, we can't do that nice trick anymore, right? They have 2 different functions. So instead, what we want to do, start with inverse sine of -√2/2. What does that evaluate to? To do that, you ask yourself, within the range of inverse sine, what was the range of inverse sine?
Negative pi over 2 comma pi over 2.
So within that range, sine of what angle is -√2/2? You can make it easier. The range is quadrants 1 and 4, right?
Yeah.
Of those 2 quadrants, which one is sine negative in?
4.
So you've now just cut your work in half. You're looking for a value between negative pi over 2 and 0. And sine of what angle is √2/2? Now you go and look at your unit circle. Unless you have it memorized.
You know what you did the unit circle with the test?
Yeah, but I told you also turn out the ones on the slides, so you can keep it in your notebook.
Yeah, you're right.
I usually am.
315 degrees.
Never get 20 degrees.
the coordinate?
I want the angle in radians.
One.
Yeah, that's not going to work. Because it's not going to give you the exact value. It's a graphing calculator.
Not even if I do the fraction.
No, because it's in terms of pi. And pi is irrational, so it won't ever give it.
7/4 pi?
Is that in the range of inverse sine then?
No.
Nope. So just do this. Quadrant 1, where's sine root 2/2?
45 degrees.
Which is what in radians?
1/4 pi.
Pi over 4.
Oh,
What's the quadrant 4 angle of that? Negative pi over 4.
45 degrees. The quadrant angle.
Quadrant 4 angle will be
Oh.
negative pi over 4.
So
that's what the inverse sine of-
the inverse of it?
That's what the inverse sine of negative root 2/2 is. Now what's the cosine of negative pi over 4?
Negative square root of 2/2. That would just be the x value. Square root of 2/2. Cosine is the x value, right? And sine is the y value. Keep it in.
That was the value. It's root 2/2. The inverse sine of sine of pi over 3. Is pi over 3 in the range of inverse sine? Again, what is the range of the inverse sine?
Yes, it's in
It is in the range. So the two functions undo each other. Inverse cosine of cosine of pi over 4. Is pi over 4 in the range of inverse cosine?
Yeah.
Yes, so they undo each other. Inverse sine of tangent of 3 pi over 4. What is the tangent of 3 pi over 4?
Square root of 2/2. Negative square root of 2.
We're looking for tangent.
That's just y over x. All right, 3 pi over 4 is 135 degrees. And then the coordinates for that is the negative square root of 2/2, cos square root of 2/2.
So what's the tangent?
1.
What is the inverse sine of -1? Again, the question is, you're looking strictly -pi/2 to pi/2. Now make your life even easier. Sine is plus or minus 1 on the y-axis. That only gives you two angles, pi/2 or -pi/2. Well, it's -1 on the negative y-axis. So which angle is that?
Pi,
Negative y,
0.
that's the positive x.
One. Negative.
That's negative y, right?
Yeah.
What's that angle?
90. Like that full angle.
True, but remember we also have a direction. So when you measure clockwise, the angle is what? Negative x.
Negative 90.
And we don't want it in degrees. We want it in radians.
Negative pi.
Pi is 180.
Negative pi/2.
Be -pi/2. So that's the inverse sine of -1. And so evaluating the inverse trig function is kind of just like reading unit circle backwards. Inverse cosine of tangent of -5 pi/4. What's the tangent of -5 pi/4?
What you said, negative?
Tangent of -5 pi/4.
1.
You went the wrong direction. That's positive 5 pi/4. So remember what to do if you're reading from a unit circle. Add 2 pi to that. Right, you want the coterminal angle.
pi/4.
What's -5 pi/4 plus 2 pi?
-3 pi/4.
Not negative.
3 pi.
It'd be positive 3 pi/4. Oh! That's literally the exact same angle. So what was the tangent of 3 pi/4? What was it?
-1.
-1, right?
Yeah.
So what's the tangent of -5 pi/4? Not a trick question.
-1.
It's -1.
Yeah.
They're the same angle. Remember, they're coterminal. When you deal with coterminal angles, that means they're the same angle because they have the same terminal point. When dealing with the trig functions, they're the same angle. And that's just the inverse cosine of -1. What is the inverse cosine of -1? And again, what is the range of the inverse cosine? 0 to pi. From 0 to pi, where's cosine equal to -1?
pi over 2.
Cosine 0 at 3 pi over 2, and that's also outside of 0 pi.
Cosine x, right?
Mhm.
Pi over 2.
Again, cosine 0. On the unit circle, where is the x coordinate -1?
Pi.
At pi. Oh, that's in 0 to pi. Inverse cosine -1 is pi. And then once you get the hang of it, it is just as easy as the trig functions. And you now just have to read the unit circle in reverse, and remember it's a restricted domain. Right, let's have some fun now. Cosine of the inverse sine of 3/5.
You would still in the unit circle?
So inverse sine of 3/5.
Oh, that would be.
Look on the unit circle. Do you see any point on the unit circle that has a y coordinate of 3/5?
No.
Nope. Oh, bummer.
It,
That won't work then.
it's undefined.
Oh no, it is defined. So now ask yourself, 3/5, is that in the domain of inverse sine? It is, right? Here's what we do. Let theta be the inverse sine of 3/5. Before I continue on, what does that mean theta has to be between? What's the range of inverse sine?
0 to 1.
Range of inverse sine.
The range.
Pi over 2.
Negative pi over 2 to pi over 2. Sine of theta would have to be 3/5. It's kind of the definition of theta being the inverse sine. That means sine of theta is 3/5. Oh, which means sine is positive, right? Where is sine positive? And remember, our theta is restricted.
First and second quadrant.
What is it?
First and second quadrant.
But we only have to worry about one of them, which is our restricted theta. So which one?
The first quadrant.
Which is what angles for theta? So all the angles in quadrant 1 are what kind of angles?
Between 0 and pi over 2.
Acute angles,
Oh, yeah.
right? So between 0 and pi over 2, non-inclusive.
Yeah.
Right? The endpoints aren't included in that.
So pi over 3, pi over 4, and pi over 6.
Are those the only angles between 0 and pi over 2? No, those are just the ones that are in the unit circle, but they're not the only ones. Oh, but if our angle is acute, can't we use right triangles? Define that to be theta. How is sine defined on a right triangle? We said sine theta would be 3 over 5. Then what is that missing length? You don't need to do any work with that if you recognize that as a 3, 4, 5 right triangle. But we said theta is the inverse sine, right?
So sine flips.
Would that mean that cosine of the inverse sine of 3/5 is just cosine theta? How's cosine defined on a right triangle?
I guess in the other.
What's cosine of theta?
Or
4 over 5. There's your evaluation. Remember I said right triangles are extremely useful in study? Yeah, look. It's not the only way you could have done. You could have also plotted it on your coordinate system and done the x over r and y over r nonsense. I like right triangles better. And that's how I'll be doing it. See that? Sine of the inverse cosine of negative 2/3. Negative 2/3, is that in the domain of the inverse cosine?
Yeah.
Let theta be the inverse cosine of negative 2/3. What's the range of inverse cosine?
0 to 5.
I should just say 4 instead of implies, but it doesn't matter. So we have restricted theta. Well, cosine theta would then be negative 2/3, right? What can we say about theta then? That is, where is cosine negative? The second quadrant, right? What angles?
Pi over 2 pi over 3 to pi.
I think you're starting off the right way. I agree to the 2d pi part. Quadrant 2, what angles?
Is x negative?
Well, x is negative, yes. What angles? Quadrant 2. What to pi?
Pi over 2?
Are the endpoints included?
No.
Right, theta will be between pi over 2 and pi. Oh, bummer. They're not acute. Which means technically, we can't use a right triangle. But I'll use the reference angle instead. Call it theta prime. Which would mean cosine theta prime is positive 2/3. Right, that's the whole point of a reference angle.
That's theta
Prime. How is cosine defined on a right triangle?
opposite of rectangle. Yeah.
Which means the adjacent is 2, hypotenuse is 3. What's our missing length?
One.
It can't be 4 because 4 is larger than 3.
But it can be 1.
It could be, but it's not. Actually, it couldn't be because then it wouldn't satisfy the Pythagorean theorem. But at least one's an acceptable, right? It's within the acceptable range. Right? What's 2 squared? What's 3 squared? 4 plus what is 9? So b squared is 5, right? What's b?
Square root of 5.
That's the missing length, 5. How is sine defined on a right triangle? Right, so sine of theta prime would be root 5 over 3. Okay, now, we're in quadrant 2. Is sine positive or negative in quadrant 2?
Negative.
Sine is positive. Oh, isn't that nice? That means sine of theta is just sine of theta prime. Because it's positive. This simplifies to root 5 over 3.
Because that's how I feel with my body.
Well, that was for theta prime. But since we're dealing with the second quadrant, sine of theta is the same as sine of its reference angle, because sine is positive. If we were, let's say we were in quadrant 3 for some reason, which we would never be for this, but let's just say we're in quadrant 3. Same setup though. Then you'd be negative root 5 over 3. Right, because sine is negative in the third quadrant. Right, so that's why I said, well, technically you can't use right triangles because you're not dealing with an acute angle. If you use the reference angle, which by definition is acute, you can use right triangles. But then you have to decide, do I have to change my answer, or do I have to multiply by a negative? And this is the way that I've always done it. I just find right triangle in trigonometry to be easier than a circle trigonometry. Tangent of the, look at this, now we're really getting crazy. Tangent of the inverse secant of negative 5 halves. Negative 5 halves, is that in the range of inverse secant? Be proud about your answer. I saw you nodding your head. Be proud. Say it loud and proud. Yes, it is. Remember the domain of the inverse secant, everything except -1 to 1. Negative 5 halves is less than negative 1, so yes, it is in the domain. What is the range of inverse secant?
What's the inverse of what?
What's the range for the inverse secant?
0, not including 0, pi over 2, union.
Not including 0.
Oh, including 0, pi over 2, not including union, including pi over 2.
It'd be the range of the inverse cosine minus pi over 2. Because cosine pi over 2 is 0, and secant's 1 over cosine. So that might be an easier way of remembering that. If you just remember the range of sine and cosine, you should be golden. or I'm sorry, range of inverse sine and inverse cosine. How do I want to write it though? Yes, with theta in. Theta in 0 to pi minus pi over 2. I don't feel like writing the union. It's too much work. I remember I did define what set minus was back when we were looking at domains, or not domain, I'm sorry, when we were looking at what was it, the function operations. I went over what set minus was, so that's all this means. That's all that notation is. I just don't feel like writing the union. I don't feel like writing two intervals. This would mean secant of theta, negative 5 halves. Where is secant negative? Again, referencing that chart that we did too, right? So for our purposes, because remember we only have one of them. Which one? So we're dealing with the upper semicircle, right? So second quadrant.
Because of what? Why?
Because we're only dealing with the upper semicircle. Remember, the range of the inverse secant is only the top half, minus pi over 2. Well, it's only quadrants 1 and 2, right? So we can ignore quadrant 3. And what were the angles of quadrant 2? What did we say they were?
Pi over 2 pi.
Pi over 2, pi. And we don't have to worry about the fact that pi over 2 is not included because we exclude it anyway. Again, technically, I can't use right triangles, but I'm going to use the reference angle instead, which would allow me to use a right triangle. Let us say that is our reference angle, call it theta prime. How is secant defined on a right triangle?
Hypotenuse over adjacent.
How about use over what?
Adjacent.
What's our missing length? Which is what? What's the length? So what does Pythagorean theorem say? What does Pythagoras say?
A squared plus B squared equals C squared.
Sum of the square of the sides is the square of the hypotenuse, right?
So it would be square root of 21.
Square root of 21 is that missing length. Right, 4 plus what is 25? 21. So b squared is 21, which makes b the square root of 21. so what we're looking for is tangent of theta. In quadrant 2, is tangent positive or negative?
Negative.
Negative.
So it would be negative square root of 21 over 5.
This would be negative tangent of theta prime. How is tangent defined on a right triangle?
Opposite or up on you?
Opposite over adjacent.
Oh, so it would be square root of 21 over 2.
Negative root 21 over 2 is our simplification. See that? Tying everything we've done over the past couple weeks together. Cotangent of the inverse cosine of 3. Is 3 in the domain of inverse cosine?
No.
Nope. Oh, that's nice. This is undefined.
Why isn't it defined?
Is 3 in the domain of inverse cosine?
But I thought that we did a problem where we could have
It's
solved.
not. Which means inverse cosine 3 is undefined, doesn't even exist. We were looking at ranges before. So, no work needed, that's undefined. It's nothing worse than spending time on an exam doing work on a question that can't even be done.
Undefined?
Who said we'd be working just with numbers?
It's undefined.
We also have to work with expressions. Sine of the inverse cosine of x.
That's x over 1.
So set theta to be the inverse cosine of x. We obviously already have a restriction on x. Let's just write that down. Just for our reference. Right, the domain of inverse cosine minus 1 to 1. So x is going to have to be restricted between minus 1 and 1. What's the range for inverse cosine?
0 to 5.
Cosine of theta would be x, again, for theta between 0 and pi. For 0 to pi, isn't sine non-negative? Sine is going to be strictly non-negative for all of our values of theta here.
Because of that. Of the
Because we're only going from 0 to pi. Right, because that's the range of our inverse cosine.
That means sine cannot be negative.
Yeah, sine can't be negative on this restriction 0 to pi. Now there are two ways to proceed from here. I think I'll do the pure algebra route. Use the identity sine squared plus cosine squared equals 1. That. That means sine squared of theta is 1 minus cosine squared, right? Or sine of theta is the square root of 1 minus cosine squared of theta. Notice, I don't need the plus or minus, right? Because we just said sine is always non-negative. Then sine of the inverse cosine of x, square root of 1 minus, what do we say cosine of theta was? X. There's your expression, square root of 1 minus x squared. This bit is also going to be extremely important in calculus. Right, not only doing expressions of the trig in terms of x, like what we did before the exam, but also dealing with the inverse and writing those as expressions of x as necessary. Really, it doesn't come in until Calc 2, when you study trig sub. Let's see. Right, so the idea is to simplify. What's the domain for inverse sine? What is it? Negative 1 to 1, right? Then the sine of the inverse sine of x would just be x. For x between negative 1 and 1. So that one was very straightforward. Let's look at the cosine of the inverse tangent of x. Again, what I'm going to do is write down the restriction on x, just so we kind of have it. What is the domain of the inverse tangent? All the numbers, right? Everything. So let's just write that down, just so we have it for reference, in case we need it. So set theta would be the inverse tangent of x. What is the range on the inverse tangent? Yeah, range of inverse tangent.
To pi over
2 pi?
2. Pi over 2.
Yeah. And negative pi over 2, right? Is that inclusive?
No.
No, right? The endpoints are not included. This would make tangent of theta equal to x. And I'm not going to rewrite the restriction of theta, we already have it. Now look from minus pi over 2 to pi over 2. What can we say about cosine?
Negative.
Cosine's negative on the right semicircle.
It's positive.
It's always positive. Can it ever equal 0? And so can cosine be 0 for that range of theta values? There are two ways to think about it. You can either look at the unit circle. Where's cosine 0? Or how is tangent defined in terms of sines and cosines?
When it says pi over 2, or like negative pi over 2, is that just 3 pi over 2?
So where would cosine be 0 in that right semicircle?
0 degrees.
Cosine 0 is 0.
But you can't include endpoints?
Well, that's what this range, I'm just saying, look at the entire right semicircle. Where is cosine 0?
Pi over 2?
And where else?
Negative pi over 2.
Which are not included.
Yeah.
Which means cosine's never 0. That's what I was getting at. Or, again, you could also just think of it, how is tangent defined? Sine over cosine, right? That means cosine can't be 0. Because then tangent would be undefined. So this is actually, yes, just strictly positive. It'll never be 0. That's good. We're always going to have positive values for cosine. So we don't have to worry about that. Now, how do I want to do this? Could set up the right triangle. Or, here's what I'm going to do. One plus tangent squared is secant squared, right? But what is secant in terms of cosine? 1 over cosine, right? Which implies take the reciprocal of both sides. Cosine squared would be 1 over 1 plus tangent squared. Cosine being 1 over the square root of 1 plus tangent squared, right? Don't need to worry about the plus or minus, because again, cosine is always going to be positive. Cosine of the inverse tangent of x. Well, tangent, we said tangent of theta was x, right? So 1 over the square root of 1 plus x squared. That would be our expression. This is purely algebra, right? This is a pure algebra argument. You could have also set up your right triangle if you wanted to, and you would have gotten the same thing. What's the domain for inverse sine?
-1 to 1.
Again, just in case. What is the range of the inverse sine?
The range,
Yep.
-pi/2 to pi/2, including them.
Let's give PowerPoint some time to get caught up because I'm starting to lag. Saved. All right, so we're going to have sine of theta is equal to x, theta from -pi/2 to pi/2. -pi/2 to pi/2. I mean, it's going to be basically the same argument as before, right? It's the right semicircle. So cosine is definitely positive. But now the endpoints are included, which means cosine can now be 0. Right? Cosine now is non-negative. Using a purely algebraic argument, start again with one of the Pythagorean identities. Sine squared plus cosine squared is 1. Means cosine squared would be 1 minus sine squared. And cosine would be the square root of 1 minus sine squared. So cosine of the inverse sine of x.
Wait, sine inverse x is, so would it be x squared?
It's going to be the square root of 1 minus sine squared. And we said sine of theta was x. And there's your expression. Square root of 1 minus x squared. And PowerPoint is still lagging, so I'm going to restart it. secant of the inverse tangent. Domain for inverse tangent. Again, let's just keep that off to the side. You probably won't need it, but better to have it. And what do we say the range of the inverse tangent was?
Power to the power to.
Open or closed?
Open.
Still lagging. I don't want it to crash. No, that shouldn't be a problem. Okay, so it's not that. I wonder if that's what the issue is. It's the 10-5 or something. I get rid of them. No, let's just hope for the best. Tangent theta is going to be x. Secant of theta. Minus pi over 2 to pi over 2. Is secant going to be positive or negative?
Agreed.
So 4 minus pi over 2 to pi over 2 is secant positive or negative? Or could it be both? strictly positive, right? We also know that 1 plus tangent squared is secant squared. No, this one's really simple. Secant would just be the square root of 1 plus tangent squared. Tangent of theta is x. Secant of the inverse tangent of x would just be the square root of 1 plus x squared, right? Domain for inverse secant.
The inverse domain of
Domain of inverse secant.
isn't it like the opposite of cosine?
Depends on what you mean by opposite.
Like what you said before, like, so I don't have to say all that.
Well, again, it depends on what you mean by opposite.
It's the domain of cosine not including positive 2.
That was range. When I was discussing that, I want domain.
It's the domain of cosine not including the endpoints. Is that how you say it?
Everything except minus 1, positive 1. Let theta be the inverse secant of x. The range of the inverse secant, 0 to pi minus pi over 2. I think this one I will just write out. And secant of theta is x. Notice over that region, cotangent could be negative or positive.
Cotangent is what, the inverse of tangent?
The reciprocal of tangent. It's positive 0 pi over 2, negative pi over 2 pi. Oh, cotangent is also not defined 0 and pi. That's a problem. How do I want to do this? I think I'm going to use triangles this time. How is secant defined?
Hypotenuse over adjacent.
X, 1, and what's the missing length? The square root of x squared minus 1. This is going to be piecewise. For 0 to pi over 2, cotangent's positive, right? How is cotangent defined?
Adjacent over hypotenuse.
Cotangent or opposite?
What is it?
Adjacent or opposite?
Adjacent over opposite, yeah, that's what I said.
I thought you said hypotenuse.
Oh, I did? Yeah, I mean, that's what I meant.
So it should be 1 over the square root of x squared minus 1, right? For 0 pi over 2. Notice I'm not including 0. And by the way, ChatGPT is wrong on this. Has to be negative pi over 2 to pi, right? Because that's quadrant 2, cotangent will be negative there. And it's undefined at 0 and pi.
So that's the reason.
Mm-hmm. Yeah, GPT is definitely wrong on this one. I could have also done a purely algebraic argument, starting with 1 plus tangent squared equals secant squared. Solve for tangent squared. Take the square root of solve for tangent, and then take the reciprocal of both sides. Right, but I would have had then the absolute value of cotangent equals something, and that's where you get the plus minus. And you'd also have to realize, oh yeah, but I can't have x equal to 1, because you have 1 over 0. And that happens at 0 and pi. So I'd still wind up with the same thing. And that should be good. That was probably the trickiest of the bunch. Do we have any questions on the inverse trig functions? So I didn't comment on this last class, I meant to. I started grading all my exams on Monday. It's been taking me one night per exam. And so tonight would be my Calc 3. Yours, if, again, schedule stays as it is and nothing unexpected happens, yours should be graded tomorrow night. So keep your eyes peeled for that. So again, all things going to plan, I'll have yours graded tomorrow night, and they'll be posted tomorrow night. If not, they should be done by the end of the week. They'll be working on the weekends, again, assuming that happens. We will start with analytic trig on Monday. This is typically when you mention trigonometry to students who have taken trigonometry. This is typically what they think of with trigonometry, is the analytic trig part. That's proving identities, solving equations, using identities to simplify expressions, things along those lines. It's probably the hardest part of trig, but it's also fun. We'll start that on Monday. Have a good weekend.